My name is Sushil Maurya and my roll number is 180. The research paper that I chose from my IA was an intelligent IoT enabled healthcare surveillance using machine learning. Introduction. Until a few decades ago, detecting diseases and anomalies in humans needed a hospital physical examination. Through technological improvements over past several years, smart IoT devices like smartwatches have allowed the diagnosis and monitoring of a number of ailments and health issues. Numerous clinical researches, for example, may be undertaken without the assistance of medical personnel. Example, monitoring heart rate, blood sugar, blood oxygen levels, and so on. Additionally, clinical data may be sent through contemporary telecommunication technology from distant areas to healthcare centers. Not only has the Internet of Things boosted human independence, it has also improved our capacity for interaction with the outside world. The IoT's growing popularity is due to its benefit of higher accuracy, lower cost, and the ability to more correctly predict the future events. Patient's body temperature, pressure rate, electrocardiogram, and EEG are monitored using sensors that are built into or woven on the body. Data on data on things such as temperature, humidity, among other things, might also be stored. By using this information, it is feasible to make reliable judgments about a patient's health. Now, about the Internet of Things Association. In an IoT healthcare system or network, the topology is a way in which the various components of an IoT healthcare systems scheme are systematically interconnected. Patients' data may be collected in many ways, with or without the use of publishers' network of sensors and other gadgets. In addition, these measures may include things like heart rate, respiration rate, temperatures, blood oxygen, blood pressure, and many more, which must be kept an eye on when it comes to ECG, EEG, and EMG. Patients may access and see the medical records through a smartphone, computer, tablet, as well as any other available electronic device. In the event that any irregularity or worsening in patient's health status is detected, the publisher may evaluate the data and give relevant information. In the healthcare IoT, each piece on the network infrastructure and the cloud has a specific role, forming a complete utility system. There have been several structural changes to the IoT systems for healthcare in the past. In doing so, it is vital to identify all the activities which are linked, which target the healthcare application when developing new IoT healthcare solution for automating a patient's monitoring. To be successful, the IoT device must fulfill the requirements of healthcare experts. That is, the design must comply to the medical standards and procedures involved in diagnostic approach, since each illness demands a unique set of healthcare measures. Now, the study that was the related study, the use of wearable technologies in healthcare has indeed been extensively researched, and a number of services are already industrialized and made accessible to the market through the advancements in Internet of Things. For several decades, the idea of remote patient monitoring has been floating and researched. A typical remote health monitoring system makes use of smartphone as a network gateway, which collect sensor signals and transmits them to medical center or data processing server, which of with or without additional processing. The Internet of Things may be used to identify ambulance, healthcare personnel, caretakers, and patients. Several medical gadgets can interact wirelessly using Bluetooth, and 100 meters or so is the maximum distance that this protocol can communicate. There are two ways that Bluetooth safeguards our data, that is, by providing authenticity and by encrypting it. In addition to its inexpensive cost and low power consumption, Bluetooth also has many advantages. This function ensures that there is less interference between connected devices when they are transferring the data. However, in healthcare applications which require long-range communication, this method fails shortly. Methodologies and experimental results. Patients and medical equipments may be tracked down and monitored in real time using with the use of RTLS and other location-based technologies. GPS is also a widely used technology in order to maintain a track of the patient. Detection is possible if a direct line of sight can be established between an object and four different GPS satellites. In certain cases, the LPS, that is, LPS network may be more efficient option. As LPS can identify and track a radio signal sent by moving object using an array of already developed receivers. Besides, RFIDs, Wi-Fi's, and LPS may be used with various short-distance communication technologies. Ultra-wideband, that is UWB, radio is preferred because it has better time resolution. Thus, the receiver can figure out the exact arrival time using a UWB-based localized system that records the difference in the arrival time to keep track of people in real time. In conclusion and the future work, the figure on the right hand side depicts the proposed block diagram, and statistical data may be displayed in the cloud, which could monitor a user's heart rate and temperature over the course of few weeks. And similarly, the data from the blood pressure sensor is also handled. Preventive measures may be taken by analyzing the data. Once the main properties of heartbeat and body temperature data have been extracted, machine learning techniques such as SVM and neural networks are utilized to develop decision models. Final conclusion: wearable sensors are required for supportive paradigms in order to track health and activity in real time. Second, it is also proven that a novel health monitoring system design allows for real-time monitoring of patients and remote access to the information. Finally, design, production, and use factors have all been examined in relation to the healthcare IoT system challenges and issues. Thank you.